For our last talk, we have one of my former coworkers and colleagues, Eamon, talking about this. I'm sorry, I messed up your name again.
That's all right.
Eamon, my bad. Thank you. It only took me 10, 20 times. But talking about a piece of software that I think is really cool called Elemental for inventory management.
Sweet.
Do you need anything?
No, I'm good. Actually,
Awesome.
Oh, I have water over there. I can.
Yeah, I got you.
Oh, thanks. Appreciate you. See if I can get this to display in a friendly way. How about that? Thank you, sir. Appreciate that. There we go. All right. Hi, everybody. How are you all doing? Everybody looks like you've been pretty much informationed out over the last 2 days, and I get the lucky position of batting cleanup in this presentation space, so hopefully you still have some attention left for me. It's elementary, my dear Kubernetes, using Rancher's Elemental to deploy Kubernetes at the edge. Normally, I would have a little clicker to walk back and forth with. I love taking advantage of a big stage. Unfortunately, I don't have one of those clickers today, so you don't get the full experience of seeing me walk around, but here, I'll do it a little bit. You all see I can walk. Isn't that great? All right, brief agenda. First of all, who are you? Why the heck should we listen to who you are? What is Rancher? Speaking of what is Rancher, what is Elemental? We were talking about those two concepts just a second ago. How do I do this stuff? I'm going to talk to you about these two concepts and about some things we're going to put together today. How do we do that? What should I do next? All these are questions, and I'm going to answer these questions for you. And then at the end, thank you. Hopefully you have learned something at the end of this presentation. So let's start with who are you? I'm Eamon. My name is Eamon Bauman. I am a field engineer for SUSE. I used to work at Rancher Labs prior to us being acquired by SUSE. I worked with Mikhail and also JVB, Jason Van Brackle, who did an excellent presentation this morning on an intro to Kubernetes. So been there since 2019 at Rancher, then absorbed into SUSE, and been there since, focusing on cloud-native technologies, Kubernetes, Rancher, Kubernetes at the edge, containers, everything in between. I like technology, plain and simple. So I'm here to present something that I think is pretty cool. It's going to be the Elemental technology built into Rancher that we use to provision Kubernetes clusters at the edge. I like baseball. So that's something you know about me. I'll share that icebreaker with you. If the Birmingham Barons had been in town, I probably would have skipped this presentation and gone and watched baseball. I'm kidding. I actually wanted to be here today, but you probably would have found me at the ballpark after that. In addition to liking baseball, I also like my dogs and a good captive audience, which all of you are being for me today. So in that spirit, I'm going to show you the best icebreakers in the world. I haven't gotten enough laughs from you folks today, so I want to show you my dogs. They're the best icebreakers I can think of. This is Krieger. He's a little red Shiba Inu. He is our little gremlin and demon. He eats everything in the house that we put in front of him or not in front of him. If there is a bag even remotely close to the edge of a surface, he's going to get into it and eat it. We have our oldest. This is Sterling. He is a black and tan Shiba Inu. You see a theme going on there. We love them both dearly, but the one on the right's a little more well-behaved than the one on the left. And I'll share two more pictures because I love showing off my dogs. This is him in the fall time looking just so pretty. Isn't he handsome? And then remember I said that we have our red, Krieger, who's a little gremlin, right? Well, there he is trying to get up onto the table and eat. He says, Dad, what are you doing up there? I'm interested. I want to see what's going on up there. So these are my lovely dogs. Hopefully that gives you a little bit of a picture of who I am as a person and what I love them about. All right, let's imagine a scenario. I want to paint a narrative that we'll walk through for the next half an hour or 20 minutes or 17 if I talk really, really fast. Let's imagine a scenario and how we're going to solve the problems in this scenario. Let's pretend that we work for a railroad company. We can make up an acronym, GSX, or I don't know, Union Specific, something like that. But it's a freight rail company specifically. We're going to be shipping things across the country. We have locomotives, we have rail cars, we are loading lumber, we are loading nonsense onto these rail cars. We need to ship that from start to be, from left coast to right coast, east to west. In our company, we make heavy use of Kubernetes. So in our data centers, we have Kubernetes that's already been deployed. Maybe it's out in the cloud as well. Your AWSs, your Azures, your GKEs of the world, let's say we have a cluster deployed out there, many of these clusters. So we're Kubernetes proficient. We've had some time to experience it, to deploy our workloads out onto Kubernetes. We know what we're doing with this whole container thing. Now, let's say we want to understand the analytics of our locomotives that are traveling across the country. We're moving from east to west. We've got all of this lumber and all of these cars that are attached to our locomotives. Let's say we want to know, I don't know, how many gallons of diesel we're burning per hour, or what the pull rate is of our locomotives, or how much torque we have at the wheels, or X or Y or Z, whatever. But we want to run some analytics here to determine if we can make our locomotives as efficient and powerful as they can be. We want to do this with Kubernetes. Why Kubernetes? Because we have that experience from running in the cloud and running on premises, and we've containerized all of our applications. And with that experience, we know the benefits that come with Kubernetes. Deploying, scaling, monitoring, logging, all of the benefits that come there, we'd like to extend that out to our locomotives in the field. We also are planning on this scenario in having a fleet of thousands. For our theoretical railroad, we don't just ship 1 or 2 trains a day, we ship thousands of locomotives. I've got 2, 3, 6, 9, 10 attached to a train. It's miles long, it has coal, it's heavy. You have to sit at a crossing guard and wait for it and go, crap, can I just get home? That's the kind of thing we're dealing with here. So it must be automated, our solution. We want to roll out Kubernetes to all these locomotives, but because there's thousands of them, I don't want to be doing this by hand. I just spoke to some of our challenges, but let's roll them down a little bit. We have thousands of devices to provision. Across all these trains in the United States, we've got piles of these devices that are going to be on board our locomotives. And they're going to be low-power devices. I'm thinking Raspberry Pis, I'm thinking little 1U computers, your NUCs, your Supermicro small boxes, 4 gigs of RAM, 16 gigs of RAM, 4 CPU. We're talking lower end of the power spectrum. They're going to be identical. So every locomotive is going to have the same stack of hardware deployed to it. 2, 3 devices deployed onto a locomotive. We've got sensors plugged into it. We want to track the performance characteristics of this thing. We can't touch all of these locomotives, though. It would not be feasible for my team of 5 DevOps engineers to go out to every single train depot in the United States, climb onto a locomotive and say, hi, I'm here to plug in stuff. It just doesn't work like that. So, because we can't touch them all, and because we're going to have to rely on untrained labor to do it, it needs to be simple. What we're going to deploy out onto these locomotives needs to be as easy as possible for an untrained person to literally plug it into the side of the locomotive, boop, hit power on, or put in a USB stick. Pretty much everybody can do that. And then again, boop, hit power on. That's all we should have to worry about. Once we've deployed all of these clusters out to the locomotives, then we've got thousands of Kubernetes clusters to manage, and with that comes its own set of concerns. Identification of all of these clusters is going to be critical. How do I know that one locomotive is not the same as another? I'm going to need to tag it with some sort of ID, right? This is locomotive 123. This is part of train 654, and so on and so on. In addition to that, we're going to have multiple devices on one locomotive, so we need a way to cluster these together. Kubernetes is obviously the simple answer here. We'll just take all these nodes and we'll put Kubernetes on it and it'll be great. But it's not simple to do in practice, but I'm going to set it up and show you how it actually can be. So we have multiple devices on one locomotive. We need to identify them and group them together in a cluster. We also need an easy way to deliver applications to all of our locomotives. We have these distributed across the United States. I've got some sitting in a rail yard in Los Angeles, down in the middle of Topeka, Kansas. I have some here in Birmingham, and I have some up in New York. I have to deliver identical applications to all of these locomotives. Track my wheels, track my gallons of diesel, track the power, et cetera, et cetera. So what does our ideal path look like for accomplishing this? Well, we have these devices, and we're going to use a lightweight operating system meant for a low resource environment, a low power environment. We also want to focus on central registration so that all of these devices can phone home and check in one central place. We also want reliable upgrades. I'm not going to be sending DevOps engineers out into the field if one of these devices goes down on a locomotive. We also want mint once, provision anywhere. Because the hardware is identical, because the locomotives are identical, just like the paradigm of containers and building that image and running multiple copies of it, we want to do the same thing with locomotives and our Kubernetes clusters. Speaking of Kubernetes, we want central management of those clusters. Can I have visibility down into each cluster on each locomotive? Is a workload misbehaving? Let's dial into it and go to locomotive or train set 4, 5, 6. Let's click on these pods. Let's look at these logs. I want simplified application rollout. You remember I mentioned we need to distribute these applications out to these thousands of Kubernetes clusters. I want that to be as easy as possible. I don't want to have to be going through and going to each locomotive and installing this stuff. I want it bing, bang, boom. I install these applications once, and my software and my automation handles the rest for me. Also, easy visibility. So I spoke about this just a second ago. I want to be able to dive into my clusters and look in any specific location if something is going wrong. But in addition to the visibility concerns of exploration, I want monitoring and logging. I want to know what the performance characteristics of these devices are. That was a crap load of slides, right? Okay, it was like 3 slides, but I hate slides. So I have this blank screen here because this is my cue to jump out of our presentation, and I'm going to actually walk through a live demonstration. We're going to flip over here to our browser, and this is the Rancher management software. Raise your hand if you're familiar with Rancher, so I don't have to. Okay, some are, some aren't. Let me give you a quick rundown of Rancher. I have a slide later in the presentation that does that, but I'll give you the 30-second elevator pitch. Rancher is a multi-cluster Kubernetes management tool. It's meant for taking your large estate of distributed Kubernetes clusters, be they in the cloud, on premises, out at the edge in your locomotives, and bringing them under one central pane of glass. I want visibility, I want logging, I want monitoring, I want RBAC, I want all these different things, and lock out Jason Van Brackle, keep him out of all of this stuff. That's important too. So security is a big concern. Rancher is going to help us with that. Rancher software was designed over a period of time ago. I worked with Mikhail and Jason at Rancher, and we built this software to manage those multiple Kubernetes clusters. It's gone through many iterations since that time. We're on version 2.7 at this point, but the core goal still remains. We're managing all these Kubernetes clusters, making it easy for you to roll out your applications. Specifically for our railroad use case, let's take a look at deploying that application. So I'm going to go to the big menu on the left with my giant hand. Hopefully everybody can see that. We're going to flip down to OS management. OS management in Rancher is the pretty name for a technology called Elemental, specifically the Elemental operator. Elemental is a technology that's going to allow us to stand up a slimmed down, very thin operating system that I can deploy to edge devices. Elemental operator is also going to give me the ability to centrally register those devices with Rancher. So from this interface, not only can I mint the operating system, but I can also create the endpoint that all of my theoretical locomotives are going to register to. If I click on Manage Registration Endpoints, we can do just that. I've created a pre-made one because if you've ever watched a cooking show, they don't wait for the turkey to bake. They take a pre-baked one out of the oven. I'm going to do the same thing. So I will demonstrate creating the registration endpoint, but we've got one that's guaranteed to work here under pre-made. When we create a registration endpoint, we're doing 3 things. First, we are telling Elemental, here is some cloud configuration you should use to set up these devices. What does that cloud config contain? You can see it right there. Things like users that I should put onto these operating systems. What device should I install this Elemental operating system onto? Well, right now it's dev NVMe 0N1. Maybe we'll change that to dev SDA. If I don't have a TPM device on my edge hardware, maybe we want to emulate TPM, there's an option for that. So anything to do with installation or top-level customization of the operating system, we can throw in here. So I can quick change that to dev SDA. And let's give our endpoint a name. Let's call it the railroad endpoint. Now, if we scroll down, that was the first thing that this does. The second thing that creating a registration endpoint does is just in the name. It gives us a registration endpoint. It gives us a place where all of our devices, once they are powered on and have networking, can communicate back to and say, hi, I'm here, I'm ready to do work. So that registration endpoint is just going to be a plain old HTTPS URL. We're setting up a WebSocket from this installed operating system, phoning home to Rancher, and setting ourselves up. The third thing that this registration endpoint does, you can see here, is add labels to devices that register. Why is this critical? Let's say we create registration endpoints for different subsets of our network of trains. Maybe I want to tag all of my east trains with a particular label, or all of my west trains. Maybe I have some older hardware that's running on these trains and some newer hardware that's running on these other locomotives. I can use this tagging here like locomotive type, and apparently I can't type, locomotive type, and let's say old, or new, or X, Y, Z, whatever. And we can actually use the label tags that we apply to these registered devices to group them together to form Kubernetes clusters. And we're gonna do just that in a couple of minutes. So when I'm done here, I hit create, and then boom, Rancher and Elemental presents me with this interface. There's my registration URL right at the top. I can open a WebSocket connection to that. I can spit out some authentication information, pretend I'm a node, and register myself if I want to. In this dropdown here for the OS version, by default, I get what's called Elemental Teal when I'm going to build my OS. Elemental Teal is the funny little haha colored name that we give to something called SLE Micro, SUSE Linux Enterprise Micro. SLE Micro, the whole idea behind it, is let's take SUSE Linux Enterprise, great for the data center, great for SAP workloads, great for everything in a traditional setting, and let's rip it apart and tear out all of the heavy crap. Let's get rid of all of the onerous stuff that's forcing us with SUSE Linux Enterprise to use these heavy virtual machines, these heavy bare metal instances. Let's strip that down, and then on top of it, let's only put in the things we need to run our containerized workloads. And then we'll call it teal because kind of the color is blue and green. Blue for Rancher, green for SUSE. Smash them together, you get teal. That's Elemental Teal. There are other versions, Elemental Orange, Ubuntu, Elemental Blue, Fedora, Elemental Purple. I'm just kidding, that one doesn't exist. But those are the different versions of Elemental we have. Today we'll use teal. I tap the build ISO here. What's happening in the background is when I submit that request, I'm telling the Elemental operator, hey, take this ISO from this OS version dropdown, and using the cloud configuration that I've specified down there, bake that cloud configuration into that ISO and spit it out for me so that I can mount it and install it on all of my locomotives and their end devices. We're going to skip ahead of that. That building ISO process takes a little bit. It's not a very simple process to build an ISO, and I don't want to stand here with just a blank screen for 5 minutes while that builds. So we'll hop back and take a look at pre-made. Here's the pre-made. The turkey has been baked. We have taken it out of the oven in this case, and I want to draw your attention down to the bottom here. I've created, and I can ambigify this a little bit. Wow, that is horrendous. All right. Machine inventory labels, locomotive 1, 2, 3. In just a minute, we're going to register 3 different virtual hardware devices. They're all going to connect back to this registration endpoint and tag themselves as locomotive 1, 2, 3. That means in our contrived scenario, we have some locomotive sitting somewhere that has 3 Intel NUCs installed into it, 3 Raspberry Pis, whatever. They're all part of this single locomotive. We want to create a cohesive Kubernetes cluster from them. So let's see that happen. What I would do first is go down to my seed images section. And here's the pre-made seed image that I just did. And there's the Elemental ISO. I could download that right now and transfer it. You don't want to watch me use horrendous conference Wi-Fi. It's actually really good here, so I'm not, belittling the conference. It's actually fantastic. But you don't want to see me use conference Wi-Fi to transfer a gigabyte image over. I've already done that work for us. So let's go over to vSphere. This is vSphere running in my home lab back up in Wisconsin. I'm from Appleton, Wisconsin. Flew down here to be with all you guys. And running in this vSphere environment, I have 2 virtual machines that have been created. Locomotive 0, Device 0, and Locomotive 0, Device 1. I said we had 3, let's create one together, then let's boot up all 3 of these and see them register back into Rancher. So, we'll go to my cluster, and my right click will fail because the user interface is horrendous on this. Let's refresh. Oh, I wonder if I need to re-authenticate. Oh, look at that, I don't even have access, wow. All right, let's connect back to Tailscale and refresh. There you go. When you don't have the VPN tunnel to back to your data center, things don't work. Once the vSphere client loads, I'll walk you through this process, but keep in mind, while we are going to build a virtual machine here, in reality what you would be doing is using an edge device. I'm going to set this device down on my workbench. I'm going to take an ISO that I've burned to a USB. I'm going to plug it in there. I'm going to mint that device, provision it, pave it with my image. Then I'm going to put it in a box and I'm going to ship it off to Los Angeles for one locomotive engineer to plug into there and run it. But we're going to use virtual for this case. So right-click, new virtual machine. Let's create a new virtual machine. I'll speed through it. We're going to call it locomotive 0 device 2, because we number indexing starting at 0. And if you don't, you should. We'll go next, next, next. I'm going to store this on my flash array. We're going to use this compatibility level. Who cares? Then Linux based on SLE 15. Remember I said Elemental Teal is SLE Micro, so it's a Linux Enterprise Micro. We're merging those two together, the blue and the green. It is a SLE derivative though, so we're going to use that for identification in vSphere. Then let's give it a tiny little bit of horsepower. We'll do 2 CPU, 4 gigs of memory, 16 gig disk is fine. Let me put it on my virtual machine network here real quick. And then the important part is we're going to mount a data store ISO file here. This is going to be the ISO file that was generated from Rancher. In that pre-made section that I minted, we're going to find that in our download list here. Click OK, connect that. Then the last piece is a trusted platform module. We want to add that VTPM because one of the key components of Elemental for identification of separate devices is the TPM built into the hardware. You can emulate it, as in the case of our virtual machine here, or Elemental provides a random generation TPM module where you provide a seed and it just generates a random string, but we'll use the VTPM for the moment. Next, finish, and now I have locomotive 0, device 1, and device 2. Let's power them on. Device 0, device 1, and device 2. All I have done in the background to prepare for this demonstration was create those 2 virtual machines and mint that ISO. I didn't do any other hidden work. I haven't already pre-installed the Elemental operating system. And in fact, you can watch as we walk through that installation here on that virtual machine. The ISO gets mounted and it's going to use, as I said, the configuration data from the registration endpoint to install that operating system. But that's not all we can do with Elemental. While that's happening in the background, let's hop back to our presentation real quick. There's our pretty picture, Elemental and Rancher. These are the 2 resources we are combining. What is Elemental? Elemental is a stack. It is the the operating system and the operator together that provide this edge solution. I talked a little bit about the operating system and the operator. The operator is seen as the central command and control portion of the Elemental stack. The OS comes with either pre-built OS images or, more importantly, there's what's called the Elemental Toolkit. The Elemental Toolkit we can use to build custom OS images based on any derivative we want, and those images by default are stored as a container image in an OCI registry. So I can actually build container images using Elemental that I can then turn into bootable edge device images. I can turn them into virtual machine VMDKs, or I can just start straight up containers using that same image. So all of that stuff sources from that same OCI image. The Elemental operator, I kind of went through this. It is our command and control. Initial config and ISO build, device registration, upgrades. You saw all of this already. With Rancher, we have the UI integration that I touched on, and in just a minute, we're going to form Kubernetes clusters from those Elemental nodes. The Elemental Toolkit is where some of the low-level magic happens in this stack. I can take container images and turn them into OS images. Or not, I can source my application workload images from those Elemental images. Toolkit's going to combine all of these components into a single OCI artifact. I'm going to have the kernel for the Linux operating system. I'm going to have initRD. I'm going to have grub for my bootloader, and so on for the low-level items necessary to bootstrap the operating system. As I mentioned, it comes in multiple flavors. Teal, that combination of green for SUSE, blue for Rancher, smash them together. We've got straight up green for SUSE Linux or OpenSUSE. We have blue for Fedora, as I mentioned, and orange for Ubuntu. The Elemental Toolkit allows us to define a custom operating system as a set of manifests that we can then version control and build operating systems with straight out of a CI/CD pipeline. In this image here, On the right-hand side is a Docker file I would use to create an elemental operating system. We're using Luit packages to accomplish this. Anybody familiar with Luit here? Okay. Luit is an overlay package manager for containers. It lets you take packages that you would install normally using Yum or apt or zipper or whatever, and instead using Luit, install them, and Luit itself packages these as container images. So you can actually version an entire root file system using a Luit package and then layer things on top of each other with Luit. And what you're doing is defining a desired configuration of packages that have been pre-built. Once you complete all that, you're going to spit out a container image. You can store that in Harbor, in Docker Hub, anything that's OCI compatible. And then the elemental CLI is the other component to this to turn it into that container image. You'll see that in a second, I hope. I'm going to run long, I think. But the elemental CLI allows us not only to install the elemental operating system onto these edge devices, but also to mint ISOs from that container image. So you can store and version and transmit your images as plain old registry OCI artifacts, and then output ISOs, VMDKs, whatever, using that elemental CLI on the other side. There's our blank screen. That means it's time to hop back to the demo. And the screen is blank. What happened here? The installation has completed and it's powered off those devices. If I go back to Rancher and look at my inventory of machines, we'll do a quick refresh here. That inventory of machines, only contains 2. Something went wrong with the 3rd. No biggie, but you see that I've registered those devices automatically back to Rancher only by virtue of mounting the ISO and powering them on. If I hop back into vSphere and power on Locomotive 0 Device 0 and Locomotive 0 Device 2, you'll see that these will show up into active status in our inventory of machines. Once they become active, we can use that locomotive 123 tag that we applied earlier to group them together into a Kubernetes cluster. I would accomplish that by going over on the left-hand side to the triple dash menu. We'll go to cluster management. When I'm in cluster management, let's create a brand new Kubernetes cluster. You'll see here, if I stump for Rancher for just a second, that I can create Kubernetes clusters using hyperscaler choices like EKS, AKS, GKE. I can also create Kubernetes clusters in infrastructure providers, your EC2s, your DigitalOceans of the world, and on premises with things like vSphere. But at the bottom, we're going to focus on the elemental box here. When I create an elemental cluster, it's going to allow me to add an inventory of machines selector template. Just like a deployment selector or a service selector or really any label-based selector in Kubernetes, I'm going to identify locomotive 123 matching 2 machines here. I scroll down, actually I should scroll up. We'll call the cluster railroad. Scroll down and we're going to make sure it's running a valid Kubernetes version. Let's put K3S 124 on there and hit create. Now, once those devices check in and are fully active, not only are they going to be able to receive OS image upgrades from the elemental operator, which has a full user interface as you saw in Rancher. So I need to go over here to OS management and then OS versions. I can increment my versions and apply changes to devices in the field without ever having to touch those devices. It also takes full advantage of the operating system's transactional upgrades. So if I upgrade this operating system and something fails, it's an atomic operation that completely rolls back in the event of that failure, which is critical if I've got this stuff running on a westbound train loaded for bear and I don't want any of this stuff getting ruined. So we've got those OS version channels to do that with. But we've created our Kubernetes cluster from these devices checking in, all by virtue of making that registration endpoint with the tag locomotive 123 and the devices check in. Let's hop back to our presentation because I'm getting right to the end of it. We'll advance to the next slide. There we go. What is Rancher? Kubernetes Multi-Cluster Manager. I went over this, kind of went a little out of order with my slides, so I apologize for that. Last thing for you. What should I do next? You can scan this QR code if you want to. If you don't, I can't control you. I don't have that power. That would be cool if I did. It's just going to take you to a GitHub gist. That just has a few links for you. Documentation on the elemental operator. Documentation on the elemental toolkit. So you're going to learn how to use that operator as the central command and control, how to use that toolkit to build your own operating systems. There's also straight up Rancher documentation so you can install the multi-cluster manager. Every single thing that I have talked about here is open source, 100% top to bottom. SUSE makes money on selling support and add-on services, professional services, contracts, things like that, but everything we put out into the world is open source. So everything I've showed you is not feature-gated, it's not open core. Go download it, play with it. You can do exactly everything I've done in this demonstration without paying me a red cent. Thank you very much. That is a sleepy dog. I wish you all lots of rest this weekend, and I'll take any questions.
Questions? No? All right. Huge round of applause. Eamon, that was an amazing way to end the conference, dude.
Thank you.
Before everyone heads out, thank you so much.
Yeah.
Sure, no questions? Last chance? Nope. All right, cool.
Cool. Well, I'll be around in the hallways if you have anything, so feel free to flag me down. I'll be here for another hour or so afterwards.
I may be a little partial, but this we're definitely going to try this stuff.
Sweet. Right on.
All right, so if I could get Ed McLean and Michael Alvis to come up here. We are going to do open sessions a little bit afterwards, and the bar is open. And thanks to Trend Micro, I think they're picking up the first $500, so feel free to help yourselves. And we'll do open sessions in a second, but I want to bring up these guys up here because they actually do most of the work. I just come up here and talk to y'all, but Ed McLean and Michael Alvis help organize this conference. So thank you guys. Ed does all the work behind the scenes except for all of the volunteers and all of the check-ins and crowd control as well. So thank you guys. Do y'all want to say a few words?
A few words. Thanks everybody for coming out. This has been a weird labor of love for all of us, and we're very happy that we got more people. And I mean, I think does anybody think the conference was worse than last year? No, you say no. The answer is no. We're hoping that you'll all come back next year. I'm hoping that we'll be here next year. I believe we will. And if not, then this was great, and I love you all. But if you manage to make it back next year, bring your friends. We'd love to have more people. We'd love to have people give us more submissions for talks. And the content has been phenomenal. It's phenomenal last year. I don't see a reason why it won't be next year. So please tell your friends, like and subscribe, and come back and watch the videos when we get them posted.
Just want to second what Michael said. Thank you all for being here. We do this for you. It really is a labor of love for us, just to help build a better tech community here in Birmingham. And we should have the videos online in probably a couple of weeks, hopefully. We're a little busy with other conferences we have to kick off, but thank you all for coming out.
All right, drink up. Trend is picking up first $500 of the bar tab, and we'll be back in here in 27 minutes for open spaces. Feel free to hang out, drink, and enjoy yourselves. Thank y'all so much for coming. We couldn't do this without you. Thank you to all the speakers. Thank you to Red Mountain Theater for letting us come here. Y'all have a great afternoon, a great weekend. It's cool. Y'all can go. You're good.